OK, I would like to boot. Hi, my name is Luise. I'm an architect. I build business application on Azure. I got awarded as an MVP by Microsoft. I'm an open sourcer. My visual identity is FF69B4. That happens to be hot pink. It's my very favorite color. I love DevOps, accessibility. I'm a punk at heart. Still a princess, though. That is very important. So loading my princess protocols. My motto is changing the world, one app at a time. My favorite number is 42. I say it depends a lot, and documentation is my love language. So my hobbies are running. I'm a healthy foodie. I love building Lego. I'm a mother of dragons, aka teenage daughters. You can find my website at m365princess.com and me on Blue Sky. And now that the system is ready, Luise X is running now. And there's a new model detected. It's called "Your testing strategy is broken. Let's fix it." Critical insights are available, so the recommended action is attend the session. You ready? OK. I guess we've all shipped bugs that we were sure were covered. And this session is your call to rethink why we test, what we test, and how we test. Who's testing software? I love this. Who's testing software too much, too extensively? You just don't know it. I would love for you to test less. Why is that? Because obviously, less is more. The only thing where that doesn't apply to is chocolate. But we've all seen apps, solutions that were held together by duct tape and bubble gum, and still the check marks are all green. And if that sounds familiar to you, like you have this high test coverage, all the builds are green, and still production is on fire, then this session is for you. I will let you in on a secret. And the secret is that green doesn't mean safe. And that coverage isn't confidence for you. So your users, they don't care at all about how many tests you've written. They don't care, and they shouldn't be caring. They do care about if your software works or if it doesn't. And I would like you to distinguish a few things. I want you to stop confusing your test quantity with your software reliability under pressure. So we test what we can count, not what really counts. To you, testing is a means, but to me, it is not to an end. Too many teams treat test coverage like that was a performance metric. But in reality, that serves only a vanity metric. And it does not add value per se, and it doesn't necessarily contribute to our ultimate goal, which would be software success, like happy users. Let's start with users. You know, those pesky people we built just like software for in the first place. Those. We measure test quantity because that's easy. We measure that because numbers feel safe, and we're drawn to numbers. So me primarily to the number 42, but just like you to just like all the numbers. But numbers and test quantity, that is only a proxy. And very often, it is a bad proxy for reliability of our software. And why is that? Because we're so disconnected from real usage and real risk and real failure modes. And if we lose that connection to real world, of that real behavior, we will stick to only what we can control. And that is code coverage, and it's test counts, and it's all the green bars, and it's metrics that look like progress, but actually do not guarantee safety at all. And what most teams actually do, smile for the picture, thank you, is they come from habit. They do not come from intent. And that means that most testing happens by gut feeling. We write what feels right, or even worse, what feels enough. And then developers very often write tests for just the code they've just written, and not for the systems, not for the real behavior. And that means that it's test after thinking. I wrote this, so I should probably test this, instead of what does that need to survive in the real world. And that won't get better with AI, because the agent that just wrote your code wants the tests to pass. So it will write the tests so that it will pass, rather than testing something that is meaningful. And then there's testing that isn't testing at all. And I call those bullshit tests. Bullshit tests, and I think you're all familiar with that, is unit tests that will mock every single thing except the actual behavior. Oh, that's you, correct? OK, gotcha. And we'll just stop that assume only the happy path. Who's happy on the happy path? Yes, I know, been there as well. And assertions that will test for the existence of a response, yes, I get something in return, rather than its correctness. And that means that is cargo cult testing. We write tests that look incredibly good, but that do not build any confidence for us at all. And then we have the misaligned goals. We often test for what is easy to simulate, but we do not test for what's most likely to go wrong. And trust me, things will go wrong. And we do not test for that, but what we can mock easily. And that means we do not model a certain behavior, but we only check the mechanics of that behavior. So yet again, that is a proxy. And why does that happen? It doesn't happen because we are all evil. So some of us are, but we're not all evil. Devs are usually trained on tools. They aren't trained on test thinking and test designing. And that means that testing becomes a checklist work, not a craft that you could master. And the real problem with that is that we're not testing what users are actually doing with our software. We're just testing what we hope they will do. And this isn't just ineffective. That is super dangerous and costly and time-consuming, and we will sweat blood and tears. So please, don't throw code over the fence and just hope it will magically work, because it won't. The fairy tales are gone. So for me, coverage, that is a signal. But it is not the goal that we should be seeking for. Because what you test in your fantasy world, that looks rather than like a unicorn. It is magical and elegant and a little bit sparkly, and it's totally detached from reality. And what your system actually looks like, that is more of a horse that is solid and messy and sometimes stubborn, but it's real and it gets the work done. So in your fantasy world, you have your linear flows with no back buttons and no retries or no dirty states. And obviously, you do not have any constraints. We have infinite bandwidth, and we have zero latency, and we have the perfect APIs, like one does. And we don't have any edge cases. And that means just that one type of user doing that one thing correctly, like every user does, right? You're that user? Love it. And then we always have the perfect inputs. And the perfect inputs would be in the valid data, the right format, and again, the happy path. And obviously, that is unicorn land. But unfortunately, we do not live in unicorn land. We live in real world. In real world, we have mismatched data, we have nulls, we have special characters. We have people that put emojis where they shouldn't be putting emojis. We have malformed fields. We have some stateful weirdness, like users halfway through a process, or dirty session storage, and we have flaky APIs and retries, and we get 4 4s. And we need to deal with real integration, and that means real payloads and real contracts and also real dependencies. And then time pressure, like timing issues or concurrency. And that is different than unicorn land. But if we test for unicorn land, but we are in the real world with our app and our solution and the users, then it's obvious that that ain't working. So there is a gap, and it's rather huge, between your test suite and your system's true risk landscape. So what good testing actually should be doing for you is it should be unlocking speed so that you do not fear to release. It shouldn't slow you down. And good testing also should improve your design because bad code is hard to test. And then it should clarify your intent. And that means that tests should show what really matters. And last but not least, it should unite your teams, because the common language then is expected behavior, rather than just like getting teams apart from each other. So in my opinion, you don't write better software in spite of tests, but you write it because of them. So tests will make your software better. It is not something that would just like prevent you from doing this. So what are we going to do about that? Once again, we need to shift left. I know, we've been told this a lot of times already from different perspectives in regards to programming, and it's always, yeah, shift left, and I get it, but here it's true as well. So we need to think upfront what we're doing instead of just like thinking after we did something. So if testing only happens after coding, that's already too late. Testing is not post-mortem validation. Testing is a part of requirements engineering. And that means that you need to ask early, what's the expected behavior? And what could possibly go wrong? And how will we know that something worked? And therefore, we need to introduce something that I call the holy trinity of good testing, and that is example mapping, and that is behavior-driven development, and that is shared testable scenarios. So what's the behavior we actually care about? Behavior is what users see. Your code, as much as you love it and we can geek out about it, that is just the plumbing. And yes, that needs to work, but your users aren't excited about it, and they shouldn't be. They shouldn't even know it exists. So please don't test that the method returns a list, because yes, of course, you can test that, and then you get a green check mark for that, and then you're just like, yay, my tests were passing, but that's pointless. Please do test that customers with an overdue account can't book a ride. Test something like that. Test something meaningful. Test expected behavior. Test something that aligns with business goals. Don't stay in your little dev box and just like do, yeah, that's a list and that's an object, and yes, I received it true. That's not what we do testing about. I would like to challenge a sacred cow, so I need to be a little bit brave now, because there is an image, a visual, that everyone who has remotely worked in testing at all saw on the internet somewhere. That's the testing pyramid. Everyone saw that in some kind of variation. And all these variations have something in common, that it's unit integration UI. And I believe that we've unit tested ourselves into a false sense of security. So that pyramid that told us, yeah, you got to test more at the unit level, and then there's like fewer the more you go to the top. And it assumes that those low-level tests are super fast and stable and valuable. And sometimes, yes, that's true. It is. But sometimes, and very often, that's just busy work. And the problem is that most bugs are not in the isolated logic. They live in flows and boundaries and with contracts and within data. And of course, I brought a meme. 2 unit tests, no integration tests. And yes, that ain't working, although the unit test did pass. Yeah, take your picture. So please prioritize the tests that catch real risk. And that means your core business flows. That means your integration points. That means real-world usage patterns. And then think about your user. What is risky user behavior? Like invalid inputs, edge cases, concurrency. And you may ignore trivial logic. So if a test does not reduce risk, delete it. Yes, please delete the tests that do not reduce risk, because they add more harm than good, because false sense of security by pointless tests. And we only test to reduce risk. And if a test does not serve this goal, we may ditch that. So you have my full permission. So you just like tell your engineering manager, Luise said so. You don't need 1,000 tests. You need the right 42. And I have some test goals. Not even talking about life goals or couple goals or fridge goals, just test goals. Like coverage of behavior, not lines of code. That would be a lovely, lovely testing goal. Then I want you to test less, but have a higher return. And I would like for you to measure assurance and not just activity. Because yet again, activity is pointless. So test design obviously starts with a variation. So test design is not just like, yeah, write a test case. That is asking at a minimum. And really, this is just like the bare minimum. That's not the princess treatment. What are the valid and invalid inputs? Which boundaries do you apply? What states can the system be in? What transitions can occur? That's not edge techniques. That is just like how you test the right way, which means we need to do equivalence partitioning and boundary value analysis. And take a look at the state transitions. And for fuck's sake, please write your decision tables. That also helps to communicate with everyone on the team when should happen what. Just like write it down, because it's not clear. Regardless of what you think, it's not clear. Real maturity as a testing software organization is the confidence in what you didn't test because it didn't matter. So obviously, every test is a trade-off. But we can use risk to decide what to test exhaustively, what to only sample, and what to leave out on purpose. Because guess what? Yes, you can just like add your meaningless test of just like, yeah, it returned something, it returned a list, whatever, and then just like seek your 98, 99, 99.9, and 100% test coverage. But it won't add value, it will just keep you busy. And there is a big difference between being busy and being productive and adding value. So good tests, they align teams. They do not just align code. And that means shared examples align expectations. Because if I do not have an example, I do not have anything to communicate about. And behavior-driven development and example mapping, that's not just buzzwords to me. These are communication tools. And we need those communication tools because if our tests describe a behavior rather than, yeah, this returned a list, then QA tests less manually. And product owns more of the quality. And we devs, we start guessing what done actually meant. And then we have just like a better foundation to talk about the thing that we are building together. Anyone using Cucumber? Okay. So behavior-driven development, that's not just Cucumber, because that is a collaborating practice, not a testing framework. And the power is in creating shared understanding across dev, QA, and product. because it forces teams to define what should this feature do, and what counts as a success or a failure of that feature, and which edge cases need to be handled. I usually say software development is a team sport. I would even go further and say software development is a people business. And BDD helps you building the right thing and not just like building the thing right. And there is a very big difference between the two. And you see this lovely Venn diagram from dev and product and QA. The point in the middle where all these circles meet and overlap. That is the shared understanding of the expected behavior. And that means we have better conversations. Because teams talk about what the system should be doing in specific situations. And this reduces the ambiguity before it becomes a bug. It also means we have concrete examples. So instead of vague stories, as a user, I want... no, ditch that. We define real scenarios. If I hear one more vague user story, I would know. I can't even. And it aligns dev, QA, and products. Because first, everyone agrees on a contract, on a behavior that we expect. And then these behaviors become the foundation for test cases and acceptance criteria and implementation. That is the very foundation of everything. And that means testing does not happen after code has happened. And if your team is doing Cucumber or Gherkin, and we write Gherkin scenarios, and no one outside of dev ever reads them, then you're not doing behavior-driven development. You're doing Cucumber-driven development. That is not the same. So I would like for you to turn your vague requirements into testable scenarios. So example mapping helps you going from, hey, let's build this feature, to here is what that actually means. And it takes just 20 minutes. Literally 15 to 20 minutes to capture your business rules, to brainstorm your example, to identify the ambiguities, and to write better user stories. And that works because it prevents those late discovery bugs like, ooh, I didn't know you meant that. Or we didn't think about this. And it also gives QA real scenarios before code even exists. And it helps product to make better decisions up front. So the best test you will ever write is the one that prevented a bad requirement from getting to devs in the very first place. And that is why testing needs to be part of requirement engineering. So let's turn your user stories into contracts. Shareable, testable scenarios, that is the glue. That should happen before and outside of the code. And everyone agrees up front, if this passes, we're done. So an example would be, if an API returns a malformed data, we should show a fallback UI. Or if a customer cancels before their trial ends, they shouldn't be charged. Something like that. That is the format. Instead of, as a user, I want to be able to. And why that matters? It reduces the finger pointing. It prevents not what I meant bugs. And it turns the quality into a shared outcome, not into a job description. But wait. There is a thing I still need to talk about. And that is testing can't save you from blame culture. Because a lot of testing strategies are not about improving software. They are about avoiding blame. And this is why we write shallow unit tests, not to validate a behavior, but to say, look, I've covered that. And also, we comment something in the code, like covered by test XYZ, to silence questions, not to build some confidence. And then QA runs some regression suite weekly, and no one knows what that protects. But hey, that's documented. And product signs off on requirements they never really read, so if it's not in the spec, it's not my fault. So you can't automate culture. You can't just do that. You can't fix a culture problem with more tech. So you can buy the best testing framework, and you can add all the test coverage dashboards, and you can plug in AI code gen for test cases. But if your team doesn't trust each other, if requirements are vague, And if blame is the operating model, then all that tooling just will automate the wrong behavior in your organization. So if your test suite is just a legal defense strategy, that's already too late for you. So without clear requirements, the devs guess, the QA reverse engineers intent, and product rewrites expectations after bug surface. But BDD, example mapping, testable scenarios all sit on the same base, requirements that make sense. And therefore, we have this pyramid. It's the shared understanding, leads to the concrete scenarios, that leads to the smart test design, and that will lead to confident releases. So requirement engineering isn't optional. It's a prerequisite for software that doesn't suck. You can quote me. And there are, of course, real fixes for cultural problems. So shared responsibility, example mapping, requirements in behavior-first mindset instead of testing as a stage thinking, and system thinking and team alignment to avoid tool worship. You will get homework, or what to do next Monday. Delete one test. That gives you no confidence and exists only to make coverage metric happy. Ask better questions like, what does success look like? Or what is the riskiest part of this? Or how will we know it works? Model a scenario before you write code. I know it's tempting to just like first open the code editor, but just like first model the scenario that you want. Try writing just like one behavior, if, and that then expected outcome. Call a cover your ass pattern, like spot it in the stand-up and name it and then kill it with kindness. And last but not least, show one example before implementation. Better testing is not about writing more tests. It's about making better decisions together. And with that, I guess, session runtime is complete. So we're doing some post-session diagnostics. Knowledge transfer confirmed. I would see so. Cultural assumptions were flagged. Practical insights were delivered. So final diagnostics. Testing strategy, coverage, understood. Confidence, redefined. The conclusion is, the coverage will make you feel safe. The confidence makes you safe, and you may choose wisely. And with that, the system state is improved. Your readiness is elevated. I'm shutting down Luise Freese. Thank you.